This is part 2 of the video for definite integrals areas. In part 1 we have completed up to question number 1 to 30. Now it is from question number 31. In the diagram, PTQ is an arc of parabola y equal to a square minus x square, where a is a positive constant and PQRS is a rectangle. The area of the rectangle is equals to, it has been given, the area of the rectangle is equal to the area between arc PTQ and the parabola. So find in terms of the dimensions of the rectangle. So first of all, we will find area under parabola. Area under parabola. So it is going to be integral. What am I going to do? We know that x-axis, y-axis is a symmetry 0 to a. This point is 0 to a. This area on the right hand side of the y-axis will be same as the area on the left hand side of the y-axis. So therefore 2 times of 0 to a. I can take 2 times of 0 to a. What is this? Every time remember, area is integral y dx. Integral y dx is the formula for the area. Remember, the formula for area is integral y dx. So y is nothing but how much? A square minus x square dx. Now, when I do the integral, a square integral is a square x square integral is x cubed by 3 from 0 to a. So when I simplify that, directly I'm writing it out, you will be getting 4 by 3 a cube. Now that is the area under the parabola. Now we know PQ. The length of PQ, this is A and A. So PQ is going to be nothing but how much? 2A. PQ is going to be 2A. Now what is being asked? Find the dimensions of the rectangle in terms of A. We have found it out, PQ. Now still we have to find it out nothing but what? QR. So for this, what else has been given? The area of the rectangle PQRS is equals to, so he has given area of PQRS is equals to area between the arc PTQ and of the parabola and this x-axis. So this area of PQRS should be equals to nothing but what? 4 upon 3 a cube. So area of a rectangle is nothing but what? Length times width. Length times width equals to 4 upon 3 a cube. What was the length just now? We got it out. 2a was the length and width we don't know. So times width should be equals to 4 upon 3 a cube. So from here we have to find the value of width. So what is that width will be equal to now? 4 upon 3 a cube divided by 2a, which is 2 upon 3 a square. So width of the rectangle is going to be 2 upon 3 a square. Question number 32. The figure below shows the part of the curve. The curve crosses the x-axis at A, B and C. Find the x-coordinate of A, B and the area of the shaded region. By using GDC, if at all you draw this one in the GDC, you will be getting the value at A, x equals to 0.753. Check your calculator and see that. And at B, x equals to 2.45. Every time 3 significant figures. Find the area of the shaded region. For part B, use the integral 0.753 to 2.45. Area means always remember y dx. So do that by calculator. You should be able to get 1.78. Question number 33. F of x equals to x ln of 4 minus x square. The graph of f is shown below. The graph of f crosses x-axis at x equals to a, 0 and b. Find the values of a and b. So again, plot this one in the GDC. You should be getting the values of a as negative 1.73 and b as positive 1.73. The graph f has a maximum value at c. Find the value of c. So from GDC, again, c value is going to be nothing but how much? 1.15. Let R be the region enclosed by the curve, x-axis and x equals to c. Between x equals to a and x equals to c, find the region R. So from minus 1.73 to 0, it is a negative area. So area is negative, f of x dx. And from 0 to 1.149, you should not take 3 significant figures. You should take the full calculator display. then f of x dx. Simplify that, you should be getting 2.07. Now, question number 34. So, for question number 30, 34, so let us do question number 34 there. The equation of a tangent to the curve y equals to ln x at a point c comma 1, find and verify that the origin is on the line, and show that derivative of x ln x minus x is ln x, and use the result to find the area. So first of all, I have to find it out the equation of a tangent to the curve y equals to ln x. So y equals to ln x, so I'll find dy by dx. Dy by dx equals to 1 upon x. Then gradient at x equals to e, gradient of the tangent will be 1 upon e. So I got the tangent. Then I need to know the point also. So in order to know the equation every time, we need to know point and the slope. So we got the slope already, which is 1 upon e. Point, we need to get it out. So y equals to ln e. So y equals to 1. So the point is going to be nothing but what? E comma 1. Now I got the point also. So the equation will be y minus y1 equals to m times x minus x1. So what does it becomes? Y equals to x upon e is going to be the equation of the tangent. So let me do in a space properly so that it can cover up that thing. So y equals to ln x was given. So first I will find dy by dx, which is 1 upon x. Then I'll find slope of the tangent, which is 1 upon e. I got the slope of the tangent. Then y equals to ln e. So y equals to 1. So the point is e comma 1. Once I get the point, then I'll find the equation, which is y minus y1 equals to m times x minus x1. So y equals to x upon e. This is going to be the equation of the tangent. Now I have to prove that this one passes through 0 comma 0. So substitute x equals to 0. So y equals to 0 upon e, y equals to 0. So therefore 0 comma 0 is on the line. Next, show that the area. So before part B, what was part B? Show that the derivative of x ln x. So use the product rule, x times ln x derivative 1 upon x. Next time ln x as it is, x derivative 1 minus, again this x derivative is 1. So we know that x and x gets cancelled, so it is 1. So again 1 and 1 cancel. So what am I left over with? Only ln x I am left over with. Now what is being asked? So let the what it says, for finding the area. So what am I supposed to do? So The area shows y equals to ln x, tangent line, and y equals to 0. So what am I going to do for that one? So I am going to find the better way is, first of all, I'll find the area of the triangle. From the area of the triangle, I'll subtract area below the curve. Then automatically I'll be getting the area of the shaded region. So what is that? Area of shaded region. Area of the shaded region equals to area of triangle minus area under curve. If at all we do like that, you'll be able to get that. So area of a triangle is half times base times height minus, I can write it out like this. First of all, half times base times height minus integral 1 to e y dx, which is ln x dx. So half times base is e, height is 1 minus, now integral of ln x is nothing but what we know. Derivative of this one is nothing but what ln x. So integral of ln x is x ln x minus x. So integral of ln x is x ln x minus x from the limits 1 to e. Now, what does that becomes now? E upon 2 minus e ln e minus e minus 1 ln 1 minus 1. So it becomes e upon 2 minus e plus e, then plus 0 and minus 1. So final answer is e upon 2 minus 1 is going to be the answer. So you can check, this is this value, this value, this is this value, and this is this value. Check with the careful with the symbols. Question number 35. The following diagram shows the part of the graph for the function f of x equals to 2x squared. Show that the equation of the tangent is 4x minus 2, x-intercept, and the shaded region expression, and find the area R. So x equals to 1, x value is 1, so we need to know the y value. So I'm going to find it out. F of 1, f of 1 is 2 times 1 square, which is 2. So the point is going to be nothing but what? 1 comma 2 is going to be the point. Now I need to find f prime x. F prime x will be equals to 4x. So the slope of the tangent will be 4 times 1, which is 4. So I know the slope, I know the point. I can find the equation of a tangent. Y minus y1 equals to m times x minus x1, which gives me y equals to 4x minus 2. Now I want to know the x-intercept. X-intercept means y should be equals to 0. So 4x minus 2 equals to 0. So x equals to 1 upon 2. Part C, the shaded region R is enclosed by the graph. Write down an expression for the R. So what is that? How do I find it out? The expression for the R? It is area under the graph minus area of the triangle. Area under the graph minus area of the triangle. So area of shaded region will be equals to area under graph minus area under the curve minus area of triangle. Area under the graph will be integral. What is that I'm going to do? From 0 to 1. 0 to 1 f of x dx minus area under the triangle. So what is the area of the triangle? What is the area of the triangle? Half times base times height. So I am going to do that. 2x square integral 0 to 1 minus, I need to know dx, minus area under the area of the triangle. So what should I do? I know the y-intercept. What was the y-intercept? Y-intercept is 1 by 2. So what's going to be the base? Base is 1 by 2 and height is 2. Base is 1 by 2 and height is 2. So half times base is 1 upon 2 and height is 2. So 2 cancels. So now find that 2x cubed by 3 from 0 to 1 minus 1 upon 2. So it should be 2 by 3 minus 1 by 2, which is equals to 1 upon 6. That's going to be the area. Now coming to question number 36. F of x equals to square root of x. The line L is a normal to the graph f at a point 4, 2. Show that the equation of the line L is given. Point A is the x-intercept. Find the x coordinate of A. In the diagram below, the shaded region R is bounded by the x-axis, the graph f, and the line L. Find the expression of R and radius area R. So first of all, I have to find it out. F of x equals to root x. So what will be f prime x? Square root of x derivative, if you remember, 1 upon 2 square root of x. Now I want to add the value at 4, 2. So gradient of the tangent will be 1 upon 2 square root of 4, which is 1 upon 4. So gradient of the normal will become equals to minus 4. So what will be the equation now? Y minus y1 equals to x m times x minus x1. So I'll be getting y equals to negative 4x plus 18. That is the equation of the normal. Now x-intercept. X-intercept means nothing but what? Y equals to 0. So minus 4x plus 18 should be equals to 0, which gives me x value as 9 upon 2. Now I need to know the area. So what am I going to do that? I am going to draw a straight line over here. So this is area under the curve plus area of the triangle. Area under the curve plus area of the triangle. That should be the easiest way of doing it out. So I need to know where this normal and this one are meeting. This point is 4. So 0 to 4, 0 to 4 root x dx plus area of a triangle half times base. What was the value of A? We know this value was 9 by 2. So this height is, this base is going to be, what is this? 9 by 2 minus base. Base is going to be 9 by 2 minus 4, which is going to be 1 by 2, which is 0.5 times height. This point was 4, 2. So the height is going to be 2 times height. So what does that becomes? Integral of root x is nothing but what? 2 by 3 x power 3 by 2 from 0 to 4 plus 0.5. So which is going to be, directly I am writing that answer, 2 by 3 4 power 3 by 2 plus 1 upon 2, which is going to be 35 upon 6. Okay, so that's going to be the answer. Now question number 37. The following diagram shows the graph at f of x equals to ln 3x minus 2 plus 1 and g of x is given. Then the area A of the region is enclosed by the curves f and g. Final expression for A, calculate the value of A, find f prime x, g prime x. There are two values of x for which the gradient f is equal to the gradient of f. Find both these values for x. So let A be the area of the enclosed between. So what am I going to do? First of all, I am going to find the point of intersections. So find the point of intersections from the GDC. You should be getting 3.77 and 8.30. Now always area will be nothing but what? Integral upper curve minus lower curve. 3.77 to 8.30 g of x dx minus integral 3.77 to 8.30 f of x dx. Then, so upper curve minus lower curve. So when you find this is an expression, so write an expression over there. So it becomes 3.77, 8.30 minus 4 cos 0.5x plus 2 minus ln 3x minus 2, 3x minus 2 plus 1. See the brackets. Don't forget the bracket. That should be the way of writing it out, the expression. Then calculate from the calculator. You'll be getting area value as 6.46. Now in part B, he is asking f prime x. This is basic one, 3 upon 3x minus 2. Then g prime x is going to be 2 times sine of 0.5x. Now in part C, f prime x equals to g prime x. So use the calculator. You should be getting x as 1.43 and another x value is 6.10. That's going to be the answer. Question number 38. A curve has an equation y equal to x times x minus 4 equation. Find the x-intercepts. X-intercepts, by using the calculator you can find it out, or you know that x equals to 0, x equals to 4. Maximum points by minimum points by using derivatives. Not this is by without calculator. So x equals to 0 and x equals to 4 are going to be the x-intercepts. Now using the derivatives. So dy by dx equals to 1 times x minus 4 whole square plus x times 2 times of x minus 4, which is going to be, I am going to take x minus 4 common. So what will be left over? 1 more x minus 4 plus 2x. So I'll be left over with x minus 4 times 3x minus 4. Now derivatives, maximum point and minimum point means first derivative should be equals to 0. So x minus 4 equals to 0 or 3x minus 4 equals to 0. So x equals to 4 or x equals to 4 upon 3. Now we need to know whether this is a maximum point or minimum point. What am I going to do for that one? The one of the method is nothing but what? I'll do the second derivative test. So I'll find dy by dx. First I'll find dy by dx, which is 3x square minus 12x minus 4x plus 16. So which is nothing but what? 3x square minus 16x plus 16. Then I'll find the second derivative, d square y by dx square, which is 6x minus 16. Then plug in this x value in the second derivative at x equals to 4. So it becomes 24 minus 16, which is 8, which is positive. So therefore this has to be the minimum value. And d square y by dx square at x equals to 4 upon 3, which is 6 times 4 upon 3 minus 16, which is negative. So therefore this has to be the maximum value. So at 4 upon 3 it's going to be the maximum. Find the coordinates of the point of inflection. For point of inflection, the second derivative should be equals to 0. 6x minus 16 should be equals to 0. So x equals to 8 upon 3. Then on your sketch, indicate the shading the regions whose area is given by this curve. So we have to draw the graph for this. got 0, 4 and maximum point and point of inflection. These are the points that you need to. Maximum point is at 4 upon 3. So this is 4 upon 3 and point of inflection is at 8 upon 3. So these are the things that you need to mention in the graph. So in this way you sketch the graph and shade. Don't forget to shade the region. Question number 39. And part C is also there, I think so. Then that one C1, C2, explain your answer in part A why the value of this integral is greater than 0 but less than 40. So we can see that this value is 10. So if at all I draw a rectangle. The area of rectangle is 10 times 4, which is 40. And the graph or the curve is a part of rectangle. Therefore area will be less than 40 but greater than 0. That is one of the way of doing. Another way of doing it is nothing but what? Integral 0 to 4 0 dx is less than 0 to 4 y dx is less than 0 to 4 10 dx, because that straight line is 10. So this is 0. Integral 0 to 4 y dx is less than, this is 40. In this way also you can prove that. Question number 38 has been done. So we shall stop here. See you in the next part. Bye for now.